Today, I want to discuss a very important and potentially hazardous operation on tankers, the pigging operation. We'll look at why it's dangerous and how to reduce the risk associated with it. Let's begin with this simplified diagram. Here you can see the shore tank. The shore pipeline, which in this example is 1 kilometer long and has a diameter of 8 inches. The pig, which is inserted at the start of the shoreline. The ship's manifold connected to the 6-inch cargo line. The ship's tank, which we'll assume is the largest on board our ship. 2,500 cubic meters in total capacity. This tank is already 92% filled, and it will be 95% filled after pigging, leaving only about 124 cubic meters of ullage space. A 4-inch vent line connected to a PV valve on top. After the main cargo pumping is completed, residual cargo remains inside the shoreline. Some cargoes must be completely cleared. This is done using a pigging operation, where a rubber or foam pig is pushed through the shoreline. Using compressed air or nitrogen, the pig is inserted at the start of the pipeline. Behind it, compressed gas is applied. As the pig moves forward, it pushes the remaining liquid cargo in front of it, through the shoreline into the ship's tank. Now here's where the risk starts to build. Let's look at the numbers. The pipeline is 1 kilometer long, 8 inches in diameter. That gives a pipe volume of about 32.4 cubic meters. The pushing gas, whether air or nitrogen, is at 5 bars or
500 kilopascals.
Now gas is compressible, unlike liquid. That 32.4 cubic meters of 5 bars. Compressed gas expands rapidly when released at atmospheric pressure. It becomes about 810 cubic meters of gas at
20 kilopascals.
That's nearly 6.5 times the usable space in our ship's tank. When the pig reaches the end of the shoreline, known as the pig trap, all the compressed gas behind it is suddenly released. It flows through the ship manifold, the drop line into the ship tank, which is a gravity-type tank, designed to hold only up to
24 kilopascals
of internal pressure. Here's the critical problem. The incoming gas is under pressure. PV valve line on the tank is only 4 inches in diameter and has a venting capacity of 1,100 cubic meters per hour. But now we are suddenly injecting compressed gas, equivalent to 810 cubic meters. Let's say PV valve is rated for 1,100 cubic meters per hour of venting. Sounds like a lot, right? But compare that to 810 cubic meters of gas entering the tank in under a minute. The venting system cannot release the gas fast enough, which leads to rapid pressure buildup. This high pressure can cause the tank to bulge, buckle, damage internal structures, even lead to tank rupture in severe cases. This is not theoretical. These accidents have occurred. Here is some of the tips and precaution to reduce the risk of pigging operation. 1. Coordinate with terminal. Always ask for details: piping length, pipe size, estimated quantity, duration, and pressure used. This helps you estimate how much gas will enter the ship. 2. Ensure enough ullage before pigging. Make sure the receiving tank has sufficient ullage. Ideally, use multiple tanks or a larger one to accommodate expanding gas. 3. Request minimum pigging pressure. Ask the terminal to use the lowest effective pigging pressure. Less pressure equals less compressed gas volume. 4. Safely use the OTH hatch if possible. If the cargo is non-toxic, non-flammable, allow open venting, and it's safe to do so. Open the OTH hatch slightly. A 1 centimeter gap at
10 kPa.
pressure can release 13,000 cubic meters per hour of air. This is far more effective than relying only on a PV valve. 5. Manually open the PV valve before pigging. Let the tank depressurize in advance to prepare for the incoming gas surge. 6. Monitor the manifold pressure closely. Assign a crew member to watch the pressure gauge at the manifold. As the pig nears the trap, you'll see oscillations in pressure. This is your signal. 7. Control the valve. Be ready to throttle or close the manifold valve as soon as the pig arrives and air starts to enter. Don't rely only on CCR gauges as it have delay timing. The remote pressure reading in CCR has a time lag. Use a compound gauge at the PV vent post for real-time tank pressure monitoring. To summarize, pigging is essential but dangerous due to compressed gas expansion. Know the pipe volume, pressure, and venting limitations. Ensure enough ullage. Use manual control and real-time monitoring. Coordinate closely with the terminal. These steps can prevent overpressure, protect the tank structure, and ensure a safe operation. Thank you for your attention. Stay safe and alert.